A pleasant day, future mathematics teachers. For today's lesson, we'll be using this PowerPoint presentation from the ninth edition of Intermediate Algebra by Leal, Hornsby, and McGinnis. And this is the chapter 7 of their book, and the title is Factoring. And for this time, we'll be focusing on solving equations by factoring. Let us first define the objectives of this presentation, or after watching this video, you'll be able to learn and use the zero factor property. I know that when you were in the high school level, you already studied different types of factoring, specifically for quadratic equations. So we are using three different ways to solve quadratic equations. Number one is through factoring, number two is computing the square, and the other one is using the quadratic formula. Here, we'll be focusing on solving equations, any type of equations using the factoring, and we'll be emphasizing the zero factor property. And the second objective is to solve applied problems that require the zero factor property. Let's start. Learn to use the zero factor property. The two tools used to solve linear equations, adding the same number to both sides and multiplying both sides by the same non-zero number, are not enough to solve higher degree equations. However, our number system has the following property, which provides another tool necessary to solve higher degree equations, and that is the zero factor property. If two numbers have a product of 0, then at least one of the numbers must be 0. That is, if AB is equal to 0, then either A equals 0 or B equals 0. So mathematically speaking, kapag ang product ay 0, ibig sabihin yung dalawang multipliers natin, yung dalawang factors natin ay may isang 0 doon. Okay? So that's the explanation there, the zero factor property. It is important to note that the zero factor property only works for a product equal to 0. And we all know that all equations can be expressed in standard form where we equate the whole equation to 0. Meaning, all the equations can be solved using the zero factor property. Consider the equation or the quadratic equation x squared minus 5x plus 6 equals 0. As we can see, this equation is being equated to 0. That means that one of the factors of this quadratic equation can be equal to 0. The left side of the equation will factor the quantity of x minus 3 times the quantity of x minus 2 equals 0. We factor this quadratic equation, and the factors are x minus 3 and x minus 2, and that is still equal to 0. This equation is certainly equivalent to the first. Walang nagbago because we only factor this quadratic equation. We only express this equation into its factored form. Notice that this is a statement that the product of two real numbers equals 0. Tama yan, ano? Sabi natin kanina, isa dito ay magiging 0 because these two are supposed to be being multiplied and the product is 0. The zero factor property says that this statement will be true if either x minus 3 or x minus 2 is 0. Therefore, x minus 3 is equal to 0. Then we solve for x. We add negative 3 or we add positive 3 to both sides of the equation. So, x equals 3. and the other factor x minus 2, which is also equal to 0, adding positive 2 to both sides of the equation by addition property of equality, you will be having x equals 2. So that 3 and 2 are the solutions of the quadratic equation x squared minus 5x plus 6 equals 0. Then we check the solutions 2 and 3 by substitution in the original equation. 2 and 3, we substitute it into all x's of this quadratic equation. So we'll be having, if x is equal to 2, so you'll be having x minus 3. We'll write the factored form of the equation. Then we substitute 2 into all x's. X is equal to 2, then x is equal to 2 here. So that we'll be having 2 minus 3 times the quantity of 2 minus 2 equals 0. Then 2 minus 3 is negative 1 times 2 minus 2 is 0. So that's true because negative 1 times 0 is equal to 0. So this is a check equation, or this is a correct equation. And we can also prove the zero factor property here, wherein which true that one of the factors of this quadratic equation is equal to 0 because the factors are negative 1 and 0. And then substituting the other solution of the quadratic equation, we'll be having to rewrite the factored form of the quadratic equation. So x is 3, x is 3. Then simplifying this further, you will have the quantity of 3 minus 3, which is 0, and the quantity of 3 minus 2 is equal to 1. And again, the zero factor property can be observed here because one of the factors is equal to 0, and 0 times 1 equals 0. Quadratic equation, this is just a review. An equation that can be written in the form 8x squared plus bx plus c equals 0, where a is not equal to 0. Why? Because if a became equal to 0, since a is the numerical coefficient of x squared and ax squared here is the quadratic term, then if a is equal to 0, this will be eliminated. This term will be eliminated, and this equation will no longer be an example of quadratic equation. Instead, that equation will become a linear equation. So that's the thing here. A must not be equal to 0. B and C can be equal to 0 for it to be called a quadratic equation, but not A. Is a quadratic equation. This form is called standard form. As you can see, if the quadratic equation is in this form, all the variables and the constant, all the terms are at the left side of the equation and being equated to 0, then that quadratic equation is in standard form. Here are the steps in solving a quadratic equation by factoring. We have 5 steps here. The first step is to write the equation in standard form. Rewrite the equation if necessary so that one side is equal to 0. That is the first thing that you have to do. That is the first step that you have to perform for you to be able to solve quadratic equation by factoring. You translate or transform the equation to standard form. Then the second step is to factor the polynomial. You will be applying the knowledge and skills that you acquire from your previous mathematics. You factor the polynomial or the quadratic equation. Then step 3 is use the zero factor property. The example that I showed to you earlier, set each variable factor equal to 0. Then afterwards, you have to find the solutions. It will depend on the type of quadratic equation, on how many solutions or roots that we can have in a specific quadratic equation, and we'll be dealing into those different types of quadratic equations later. Then solve each equation formed in step 3. And then the last step is to check each solution in the original equation. Here is an example. Like for example, we have this quadratic equation 2x squared plus 5x equals 3. This quadratic equation is not in the standard form because the right side of the equation is not equal to 0. So what we have to do is to transform this into a standard form. So we add -3 to both sides of the equation. So the standard form of the equation will become 2x squared plus 5x minus 3 equals 0. After transforming the equation to the standard form, the second step is to factor, and the factors of this quadratic equation are the quantity of 2x minus 1 times the quantity of x plus 3. Then we equate it to 0. Then the step 3 is to apply the zero factor property. These two factors are both equal to 0 because we know that one of these factors can either be 0 because their product is equal to 0, and that is the zero factor property. The step 4 is to solve each equation, meaning we solve for x. Then, since we have 2x minus 1 equals 0, we add a positive 1 to both sides of the equation, and you'll be having 2x equals 1 by addition property of equality and dividing the whole equation by 2. That's the division property of equality. X is equal to 1/2. Here, you will have x plus 3 equals 0. Then add -3 to both sides of the equation for you to arrive at x equals -3. Meaning the solutions of this quadratic equation are 1/2 and -3. We move on to the last step, which is the checking each solution in the original equation. Meaning we substitute the values that we get to the original equation. So, substituting 1/2 to all x's, here you will have 2 times the quantity of 1/2 squared plus 5 times 1/2 equals 3. Simplifying it further, 1/2 squared is equal to 1/4 times 2 is equal to 1/2. Then 5 times 1/2 is equal to 5/2 equals 3. Simplifying this, 1/2 plus 5/2 is 6/2, and 6/2 is equal to 3. So 3 is equal to 3. So that's true. And then the other solution, which is -3, we substitute it into all x's. Then by substitution, you'll have 2 times the quantity of -3 squared plus 5 times the quantity of -3 equals 3. Simplifying it further, you will have -3 squared is 9 times 2 is 18. Then 5 times -3 is -15. 18 minus 15 is equal to 3. Then 3 equals 3, and that makes a true equation. Meaning, the solutions that we got using this factoring process is correct. So the solutions are 1/2 and -3. Note there are two solutions here. Two different solutions. Let's have another example. The quadratic equation 9x squared equals 24x minus 16. Again, solving this by factoring, the first step is to translate the equation to the standard form. The standard form of the equation would be 9x squared minus 24x plus 16 equals 0. Then we factor, this is the second step, factoring 9x squared minus 24x plus 16, you'll have 3x minus 4. The quantity of is raised to 2. Okay, so meaning the factors of 9x squared minus 24x plus 16 is equal to 3x minus 4, the quantity of 3x minus 4 times the quantity of 3x minus 4. And then applying the zero factor property, you'll have 3x minus 4 equals 0. Then we add positive 4 to both sides of the equation to solve for x. 3x equals 4. Then divide the whole equation by the numerical coefficient of 3 of x, which is 3. Then by applying the division property of equality, x is equal to 4/3. Take note that in this case, there is only one solution because the trinomial is a perfect square. The solution is only 4/3. Okay. Here's another example. 7x squared plus 42x equals 0. This quadratic equation is in standard form already, but there is a missing constant term here. And we do not have any problem with that because as I mentioned earlier, for it to be called a quadratic equation, a must not be equal to 0. Only a must not be equal to 0. But b and c can be. In this case, we have a value of a, which is 7, so that's not a problem even if we have a missing constant term. Comparing this quadratic equation to the standard form, ax squared plus bx plus c equals 0, we see that c equals 0, and we can still apply the zero factor property. This is the first step. It's already in the standard form, and the second step is to factor by looking into the common factor of the two terms, and the common factor of the two terms 7x squared and 42x is 7x. So 7x times the quantity of 7x squared divided by 7x is x. 42x divided by 7x is 6. The factors are 7x and the quantity of x plus 6 equals 0. Applying the zero factor property, you will have 7x equals 0 or x plus 6 equals 0. Then you solve for x's. Divide the whole equation by 7, x equals 0. By addition property, we add negative 6 to both sides of the equation, x equals negative 6. Here, we have two solutions, and the two solutions are negative 6 and 0. Remember to include 0 as solution. Take note, sometimes students do not include 0 as a solution of the quadratic equation, kaya nagkakamali sila. So 0 is still should be included in the solution because it's still a number. Solving equation of degree 3. So we are already done with the quadratic equation. We move on to solving equation of degree 3. Here we have x cubed plus 2x squared minus 9x minus 18 equals 0. The first step is to check if our equation is in standard form, meaning if our equation is being arranged in decreasing order, looking into their exponents per term, and it must be equated to 0. Then factor by grouping. As you can see, yung magkatabi, pwede nating i-factor because they have common factors. X cubed plus 2x squared, that's the first group. The second group is 9x and negative 9x minus 18. The common factor of x cubed and 2x squared is x squared. So x cubed divided by x squared is x. Then 2x squared divided by x squared is 2. The common factor of negative 9x and negative 18 is negative 9. So that negative 9x divided by negative 9 is positive x. Negative 18 divided by negative 9, that's positive 2. And as you can see, we have here common factors, which is x plus 2, so that we can rewrite x plus 2 as 1 here, and the another factor is x squared minus 9. So we will write x squared minus 9 here. The factors are x plus 2, the quantity of x plus 2 times the quantity of x squared minus 9 equals 0. And we can still factor x squared minus 9, and take note that this is the difference of two perfect squares, and the difference of two perfect squares can be factored easily by looking into the square root of x squared and the square root of 9. So you'll have the sum and the difference of their square roots. That is why x squared minus 9 can be factored as the quantity of x minus 3 times the quantity of x plus 3. Since this is an equation of degree 3, we'll have 3 different factors, and those are x plus 2, x minus 3, and x plus 3. And we are expecting 3 different solutions here. Using the zero factor property extended to include the 3 variable factors, you'll have x plus 2 equals 0, so x is negative 2. X minus 3 equals 0, so x equals 3. And the last one is x plus 3 equals 0, so x equals negative 3. The solution set is negative 3, negative 2, positive 3. Please take a look at this when you write the solution set of a certain equation. Then you write it in increasing order according to what appears first in the number line from left to right. So basically, those are the ways of factoring, applying the zero factor property. This time, how do we apply, or how do we use a quadratic function in an application? Suppose that we have this problem. The manufacturer of weather radios has determined that the revenue R from the sale of radios can be approximated by using this equation R, and R stands for the revenue, equals negative 100p squared plus 1300p, where p is the selling price of each radio. Question is, what is the selling price of the radios if the revenue is 4,000? So our problem here is to solve for p, because that is what is being asked in the problem. And we know that R is equal to 4,000 here, since that's the revenue. So we'll have an equation, negative 1000p squared plus 1300, negative 100p squared plus 1300p equals 4,000. We simply substitute 4,000 to R, since R is the revenue. And then we now solve this quadratic equation for p. Again, what is the first step? The first step is to transform the equation to standard form, meaning the equation must be equated to 0, or the right side of the equation must be equal to 0. So the standard form is negative 100p squared plus 1300p minus 4,000 equals 0. Then divide each term by negative 100, since as you can see here, all these terms are factorable by negative 100. Dividing the whole equation by negative 100, you have p squared negative 100 of negative 100 p squared divided by negative 100 is equal to positive p squared. 1300 divided by negative 100 is negative 13p. Then negative 4000 divided by negative 100 is equal to positive 40. In that manner, we can solve this quadratic equation easier. So factoring this, you'll have p minus 5 times the quantity of p minus 8 equals 0. And then applying the zero factor property, p minus 5 equals 0 and p minus 8 equals 0. So p equals 5 and p equals 8. That is why we can conclude that if weather radios are sold for either $5 or $8, the revenue will be 4,000. Since this problem is a quadratic equation, so we have two options here, and these two solutions are both acceptable. And thank you very much for watching this video. I hope that you are all safe, staying in your home, studying our lessons. Keep safe everyone, God bless, and hope to see you soon.